I'm Madison.
Hi, I'm Jaidyn. According to National Geographic, every year about 8 million tons of plastic waste escapes into the ocean from coastal nations. That's the equivalent of setting 5 garbage bags full of trash on every foot of coastline around the world. Plastic pollution is a very important issue in today's world, prompting the United Nations to begin writing a global treaty. But in 2016, a groundbreaking discovery was made that could make a significant impact on the issue: an enzyme called PETase, which can break down highly crystalline plastics used in things such as single-use plastic bottles, in some clothing, and in carpets. This newly found enzyme can create and provide new opportunities for bio-based plastics to be recycled. In today's speech, I will be discussing how the enzyme was discovered, how scientists are engineering it to be more effective, the benefits of using the enzyme, as well as the possible effects on the environment. The naturally occurring enzyme has been found in 3 different places around the world. The enzymes are found in a Japanese plastic bottle recycling plant, a Pakistani landfill, and a highly polluted site in Houston. All 3 areas are linked to plastic waste, a remarkable discovery to scientists that bacteria could evolve into a plastic-eating enzyme that uses the pollution to its advantage to carry out biological functions. According to Adele Peters from Fast Company, 3 years ago, a Japanese scientist discovered a tiny new bacteria with an unusual ability. The organism, which lived in soil near a plastic bottle recycling plant, could eat plastic. A year later, a plastic-eating fungus was discovered in a landfill in Pakistan. The year after that, a college student discovered a plastic-eating bacteria in a polluted site in Houston. Harry P. Austin, one of the lead scientists, states that in response to the accumulation of pollution in the biosphere, it is becoming increasingly recognized that microbes are adapting and evolving enzymes and catabolic pathways to partially degrade man-made plastics as carbon and energy sources. Scientists are now engineering the enzyme to be more efficient. Since its discovery, scientists have begun studying and experimenting to see how the enzyme can be improved to solve the pollution problem. After some time, UK scientists accidentally created an enzyme that can break down plastic bottles in days rather than weeks, about 96 hours to be precise. But since the discovery is so new, there is still some work to be done. Callum Maxwell from The Gist states that a team from the University of Portsmouth and the U.S. Department of Energy's National Renewable Energy Laboratory collaborated on further research. While identifying the structure of the enzymes, they accidentally engineered an even more efficient enzyme than what nature had already provided. This mutant of PETase has an added appetite for an additional plastic, PEF. Amanda Dupont and Bonnie Hall state that our goal is to engineer a PETase with a higher efficiency of hydrolysis. The first step in the process is overexpression and purification of the enzyme. The mutants will then be engineered to improve enzyme activity under the desired conditions. An optimized PET enzyme capable of degrading plastics can be the first step to repairing our polluted ecosystems. This enzyme also has the ability to increase the amount of plastic recycled in the world. Not only can it be used to reduce the amount of pollution caused by plastics, but it can also increase the efficiency of recycling. This enzyme breaks down PET into its primary components, which can then be reused to make other plastic products. What makes this enzyme so important in the future of recycling is that it is much cleaner than using petroleum and crude oil, as they do now. Adele Peters from Fast Company states that, like some other new recycling technology, using enzymes has advantages over traditional methods of shredding up old products. The plastic doesn't have to be clean and can be broken down completely. We take these plastics back down to some of their precursor components, and then they are made in a better position, then to be reused and reincorporated into new materials. Creating precursors for making plastic rather than recycling whole plastic into lower grade material might incentivize more recycling because there's a better market for the final product. The hope is that by continuing to optimize the protein as far as possible, the millions of tons of PET waste that already exists in our environment can, over time, be broken down back into its raw materials. This would allow for legitimate recycling of the products required to manufacture PET in the first place and prevent the increasing risk of microplastics building up in the environment. Lastly, using the enzyme could have effects on the environment. With pollution as destructive as it is, this enzyme could significantly help reduce pollution on both land and in the sea. On land, initiating an improved way of recycling would be much simpler than fixing the pollution problem in the oceans. Since the enzyme is newly discovered, scientists cannot conclude whether using PETase would damage the aquatic ecosystems. Most likely, a better way of collecting the plastic in the oceans would need to be found in order for the trash to be taken inland and then to a recycling facility. Callum Maxwell from The Gist states that currently only PET and PEF have been identified as a consumable plastic. However, with the continued study of these fascinating proteins and enzymes that exist or will come to exist, scientists hope to identify pathways to break down all the plastic waste that exists on our planet. Years into the future, we could be looking back at this discovery made from sludge located at a recycling center as one of the most important in the fight against plastic waste. As fossil fuel resources become ever scarcer and the plastic waste pile continues to grow, the potentially irreversible damage caused as a result of them becomes ever more evident and drastic. The PETase enzyme could solve the plastic pollution all across the world. Since Japanese scientists first discovered the enzyme at a plastic bottling recycling plant in 2016, many organizations have tried to learn and discover how to make the enzyme more efficient in order to increase plastic recycling and hopefully reduce pollution on land and in the oceans. As the earth becomes increasingly more poisoned by plastic waste, this enzyme could be the saving hope in order to reverse the damage that has been done and save the environment. If all things go according to plan, introducing this enzyme into recycling facilities will make huge strides in the amount of plastic that will be produced moving forward and will encourage people to reduce, reuse, and recycle. Thank you.